Hey everyone, I'm going to do a quick mini lesson here for function notation, evaluating functions, etc. Notice some trends on the homework assignment. So functions and function notation is really important for this class. When we use function notation, it means that we use this notation here, y equals f of x. Means that we have a function named f, okay, and we read this as y is a function of x. Another way that we can think about that is that if we input x, we output y, okay? Input is always in the parentheses, equals the output. Y, the output, is a function of x, the input. Okay, so that's really important, being able to sort of deconstruct it in from function notation to also writing it as words, or from words being able to write it as a function. So again, here, if I say the output y is a function of the input x, if each x value has exactly one output value, that is a function. Okay, if we have more than one output for an x value, it means it's not a function. Another way we can say this is the value of the output depends on the input. Let's look down here at a graphical example. So when we have the horizontal axis, that is always represents our input, okay? Our input. And the vertical axis is always our output. So when I look at this, I could say that if I input the number of items sold, I get an output of revenue. And each one of these things I can write as an ordered pair as well. When I sell 0 items, I have 0 revenue, 0, 0. This one here, when I sell 90 items, I have a revenue of $2,700 because it's telling me revenue in dollars. All right, so let's look at the notation again. We can say y equals f of x, meaning we write that y is equal to f of x. That's a translation. Every time you see a parenthesis, you can think of using the word of. So let's look at this. If I say that y equals f of 50, okay, I can translate that into words, right? Y equals f, I have a parenthesis of the thing inside 50. Okay, well, let me look at my graph here, all right? If I input 50 items sold, I get an output of 1,500. Here's my items sold. Let me go to 50, input 50 items sold. I go up here, I get an output of 1,500. So f of 50, input 50 items sold, is equal to or gives me a revenue of $1,500. I can say that as f of 50. The of refers to these parentheses. F of 50 is equal to $1,500. I input 50 items, I get an output of $1,500 revenue. If I want to put that in context, I can say when we sell 50 items, right, number of items sold is 50, right here. The revenue is $1,500. I can write this as an ordered pair as well. When I input 50 items, or when I sell 50 items, my output is $1,500. Input, output. Okay, my input is number of items sold. My output is revenue in dollars. All right. So let's look at here. I can determine if a relationship is a function by using the vertical line test, if you read the textbook, right? So if I look at this case, this first example is a function. If I draw a vertical line, and let me actually actually do it with a little help here. Okay, if I draw a vertical line and I move that vertical line horizontally, you can see here that every time I move it, it only goes through exactly one point. Okay? No matter where I move it along the curve, it only goes through exactly one point. If I look at this next example, this one is not a function. This is not a function because if I look here, if I draw a vertical line and I move it horizontally, we can see in this case, except at the very tip here, if I move it across this relationship or this graph, it always, or most always, goes through two different points. That is telling me by the vertical line test that it's not a function. Okay? And this last one is also not a function. Same idea, because if I take this vertical line and I use that to test to see does it go through more than one point? Yeah, it does. Okay, x value has two possible points, right? So let's say that this input here is 1. I would input 1 and my output up here is, let's say, +3 and -3. I have two different values for the same input. Okay, so how do I do that? I look at the graph, I see if I draw a vertical line, does it intersect the curve more than once? If it does, that means that I don't have a function. It can still be a relationship, but it's not a function. All right, evaluating and solving functions. A couple people had some confusion, it looks like, on the homework. So here's my function, f of x equals 3x plus 1. So evaluate and solve have really specific meanings in math, okay? So if I evaluate the function, it means to find the value. Find the value when I'm given an input. Solve means that I'm given the output. I'm given the output and I want to solve for the input. And this is going to help us determine when to use solver as well, because that is why it's called solver. I'm given an output, I can solve for the input. Okay, so I know that the input is the thing inside the parentheses. Input 0, I want to evaluate the function to find the value of y. So here's my function, f of x. I'm just going to say f of 0 means everywhere I see an x, I'm going to put a 0. 3 times 0 plus 1 is equal to 1. All right, I can look graphically here. When I input x equals 0, y equals 1. Input 0, output 1. I can write this as 0, 1. This is evaluate. Given the input, I find the value or evaluate to find the value of y. In this case, I don't know what x is, but I'm given y, right? I always know that I can write a function as f of x equals y. So in this case, I'm given y equals 4. I want to solve for the x value. Solve for the x value. So I'm given y equals 4. I want to solve for x. So let me go here. If I'm given y equals 4, I can do this algebraically. But I can also, we're going to use solver to do that. But if y equals 4, well, here's my y-axis, here's my x-axis, here's y equals 4. I'm going to travel over until I hit the graph. So I want to find what's the x value. The x value is 1. X equals 1, y equals 4. Okay? So I solve for the x value. Given y, solve for x, okay? And in this case, I get 1, 4. Now, I could do this algebraically as well, right? Here's my function, f of x equals 3x plus 1. I have f of x equals 3x plus 1. I know, and so this I could write as equals y equals 4. So I have 3x plus 1 equals 4. All right, I can solve for x algebraically, subtract 1 from both sides. I get 3x equals 3. Divide both sides by 3. I get x equals 1. So I solve for x equals 1, y equals 4. All right, again, so in this one, I'm given, I said f of 0 equals what? Well, I know I can always write f of x equals y, so I have f of 0 equals, I don't know what is y equal to. I want to evaluate. I'm given the input. I have an input x equals 0. I want to evaluate to find y. So I have my graph here. So when I input 0, x equals 0, I'm going to travel up until I hit my function 2. 0, 2. So when I input 0, I output 2, 0, comma 2. So in this case here, I evaluated because I was given the input. If I look at this case, f of x equals 0. Well, I can always write this as f of x equals y. So I'm given y equals 0. So I want to solve for x. So this is my y value. So I want to look at my graph. In this case, I'm given a graph. So I want to look for where is y equals 0. Okay, well, here's 0. I'm going to travel over. I need to solve for the x value. All right, so it's right here when x equals 1, y equals 0.